Okay, thank you very much, and congratulations to all of you to make it to the first lecture after the gala dinner last night. So the first presentation this morning is going to be given by Michael Laterveer. He's now the curator of Rotterdam Aquarium and has been at Rotterdam Zoo for the last 14 years. With Dirk Peterson, who's the lead author of this presentation, he founded Seacorp and is currently on the board of directors. And this morning he's presenting public aquaria and scientists work together towards the conservation of the threatened elkhorn coral Acropora palmata.
Thank you, Heather. Good morning, brave ones. I'm going to be brave as well. I'm going to give the lecture that Dirk gave at the International Aquarium Congress, and I thank the EUAC that we can give it again here. And Dirk did a wonderful job of writing out the text with these wonderful images. I'm going to try, I'm brave myself, to read this text. I hope I'm able to do that. Normally I'm pretty free in talking, and I like that. So thanks for giving this lecture. The success of this project was made possible because of the collaboration of more than 20 public aquaria and research institutions under the umbrella of Seacorp. After giving some information on Seacorp and its success story, I would like to draw your attention to the threatened elkhorn coral and how public aquaria can contribute to its conservation. Seacorp means sexual coral reproduction. It's an initiative of public aquaria and research institutions and was started by Rotterdam Zoo in 2001. After 7 years, we have more than 50 members in Europe, USA and Japan. Seacorp aims at carrying out research to develop techniques for breeding corals in aquaria and aquaculture. Meanwhile, Seacorp is an important international platform for exchanging techniques and knowledge. The techniques are made accessible through workshops and publications to everybody who shares our goals to conserve one of the most threatened ecosystems, the coral reefs. We believe that using sexual reproduction in aquaculture and aquaria does contribute to conservation. Aquarium livestock can be managed more sustainably. Techniques can be used for breeding programs and to restore damaged reefs. Last but not least, millions of people visit every year zoos and public aquaria around the globe, which offers a perfect opportunity to raise public awareness on the critical status of coral reefs and its key species. In 2004, we presented Seacorp before. At that time, we had the first idea of the potential of Seacorp. The initial 3 years were used to develop basic techniques on how to control sexual coral reproduction. From 2004 to 2008, Seacorp slowly grew and expanded its network. More and more public aquaria, as well as leading scientists of different fields, have joined Seacorp since then. This led to a success story and opened doors to reach goals that we would not have imagined a few years before. We have learned how to collect coral gametes during mass spawning events or from laboratory colonies. We have learned how to collect larvae from brooding colonies in holding tanks, or even from coral colonies in exhibit tanks. Thousands of larvae of different species were settled on different ceramic tiles behind the scenes. And by the way, these ceramic tiles, a large part of them were funded by a Seacorp fund, an EUAC fund last year. So, last but not least, we were able to grow corals successfully from captive settled primary polyps, and to produce large quantities of sexual recruits for stocking our exhibits and for exchange with other public aquaria. As Max Janssen already said, he did a lot of that, and it's very good and nice to see that it's happening. This knowledge made it possible to work on one of the most delicate coral species that we know so far. Until recently, it was almost impossible to keep the elkhorn coral, Acropora palmata, in captivity. The Elkhorn coral used to dominate shallow reefs areas through the Caribbean. Here you can see one of the last remaining populations, which still regularly reproduce every year. This is actually the population with which we work in Puerto Rico since 3 years. You can see there's a lot of fish in there, and the water is murky. And sadly, this is one of the few stands still standing there. So it's very shallow, between 2 meters and 5 meters depth, and a lot of wave action. Really sadly, this is how 95% of today's Elkhorn coral population look like, this picture. With the Elkhorn coral disappearing, species richness drastically decreases and the reef will disappear. In 2006, the staghorn coral, Acropora cervicornis, and the Elkhorn coral were listed as threatened under the US Endangered Species Act. This was the first time that a reef-building coral was officially listed as threatened. Scientists tried to develop effective techniques to restore the Elkhorn coral in the Caribbean, however not with significant success. Regarding the life cycle and the sexual reproduction of the Elkhorn coral, it releases huge amount of gametes in the water column during 1 or 2 nights shortly after full moon in August. The gametes drift to the water surface where fertilization takes place. After a few days, a larvae, called a planula, develops, which may settle and change into a primary polyp if suitable substrate is present. The initial primary polyp is very small and is easily killed by algae or sediment. Once it has reached a size of a few centimeters, it is less vulnerable and reaches a more stable stage. Usually, after 4 to 5 years, the colony has developed branches up to 20 centimeters long and reaches maturity. In the life history of Elkhorn corals, this is the most crucial stage. Most of the eggs, larvae and primary polyps will not survive. As a consequence, although sexual reproduction of the Elkhorn coral is still observed in the Caribbean, almost no recruits are found. Therefore, restoration attempts should help to overcome this bottleneck. The Elkhorn coral is almost exclusively found in shallow wave-exposed areas where animals wouldn't have any chance to live without being protected by the Elkhorn coral as a main reef frame-building coral. These pictures are taken at the beach where the Elkhorn coral occurs in Puerto Rico. Here we are collecting the gametes in August. You can see that that's really big waves of 8 meters and higher. But this is the same beach in August. The conditions are completely different and only then it's possible to dive safely in the water. Here we organize the Sea Corps workshops since 3 years. At the beginning of each workshop, we give lectures to the participants to obtain the necessary background on the work to be done. The most important event for the participants of each workshop is the mass spawning of the Elkhorn coral, which takes place 1 to 2 nights at the Tres Palmas beach. This is a very exciting moment for us all. Actually, on this picture you can see Mike Britson, who is one of the members of the Sea Corps Board of Directors and who is actually coordinating the US Aquaria. We are using special plankton nets to catch the gametes at the moment when they are released by the corals. Here you can see the divers getting ready to collect the coral spawn. The divers observe the coral looking for specific egg sperm bundles. Here you can see Mike Britson, and he's attaching a bottle to the net. There's a little bit air in the bottle, so the net is drifting because the air in the bubbles goes up. Look also how the divers move. They do not do it voluntarily. It's really the wave action that's rocking you around. So you have to be a very good diver and very careful in this area Now they're still looking for the egg bundles, and so they're a little bit away from the colonies. But if you really get close to the colonies, you have to be really careful, of course. Because of the film, there's a lot of light on it, but normally you don't use your light. Here is pointed out some egg bundles that are coming up within the polyps, mostly in the middle of the colonies. Here you can see the bundles located in the single polyps on the colony surface. The bundles are then released in about 15 to 20 minutes. And it's different than Dominique showed. For the Monstera species, they are released one by one. It's very slowly. It's not a total release of one colony. You see them coming off one by one, which makes collection difficult. One of the techniques you can use is to turn in eights. So you make a kind of vortex, and in the middle the bundles collect, and then you go through it with your net. So if you have done it a few times, it's quite easy to collect a lot of bundles. There are just a few in there, as you could see, on the top of the bottle. Let's see where I'm at. Well, I'll leave this one. Then the bottles are brought back to shore, and you can see that on the top of the bottles, the orange stuff that are still the full bundles with eggs and sperm in it, and they drift to the surface. And the next thing you do is breaking up these bundles, and then the eggs will drift to the surface, and the sperm will go through the water, and the water will get milky, and you need a kind of lemonade color to have a good fertilization. So that's what I'm doing here, is getting out some water with sperm, so to have the right sperm concentration with the eggs. We also mix, each bottle is actually one colony. So what we do here, you can look at where the colonies came from, where the bottles came from, and you can mix specific colonies with each other. For research, we bring these some egg bundles especially to researchers. We know which colony it's from, and they can do research on the fertility of the sperm. For aquaria, we mostly mix as much colonies together to have a genetic diverse fertilization. This is in the lab. So normally we do it on the beach, we shake it. You can see here the color, it's a bit lemonade-like, and then fertilization takes place. In the beginning, we worked with static bins. These bins were set up with a layer of water in it, at 25 centimeters, and you have to steer it. Not 1 hour, not 2 hours, 24 hours, and 4 days in a row. And you cannot leave it, and then so you have to be 24 hours on a row. Normally we have about 15 bins, 2-3 people working on it during night shifts, and after 2 days, after 1 day, you try to get the water clean again. Some eggs die off, so the water gets dirty. You have some bacteria growth on top, and so you need to clean the water. And also to try to get rid of this bacterial layer. And it's very labor intensive and it's very hard to do, but it's a successful technique. But now we improved it. Now we have hoses running to the sea, and in houses near shore we set up a real laboratory. The pumps provide these bins we have there with fresh seawater. And so we can make flow-through systems for coral larvae rearing. Here you can see the chrysals made by Mary Hagedorn and the Shed Aquarium, and they work very, very well, and it enables you to really culture thousands of coral larvae. You can see the orange stuff on top it's really thousands of larvae. You have also the possibility to have a transportable bin. And in this bin you have a chrysal. The bin and chrysal go to a certain area. You can provide it to any researcher or anybody who wants to collect around the world. You set up the bin, put fresh seawater in. It's a smaller system, as you can see, and it works perfectly. Every year we make improvements on these chrysals. And then the larvae are bottled. You see the small dots are larvae which are 3 to 4 days old, not yet settlement competent. The time that you have to send these larvae is very important, and the difference between species. So we know now it for the elkhorn coral, and Dominique also told something at Guadeloupe, that some of the larvae which he sent over were already settled. That means that they probably are a little bit too late with the transport, but it's everybody who flies and you have to plan it all, and it's very difficult. So it's, that's really a crucial stage if you want to transport the larvae back home to your institutes. This is Omaha Zoo, Mitch Carl. He was most successful the first time. You can see here the polyps on the sea-core tiles. And there's a big development. And you can, with these techniques, you can develop a lot, you can culture a lot of corals at once in your tanks. And really see the growth. After a few months, like 6 to 7 months, you need to set the tiles on live rock, because the coral is getting bigger and they are going to touch each other if they stay on these tiles. We really have good growth, but they're very sensitive. If something goes wrong in the system, you see a kind of shutdown reaction of these corals. They stop growing, they stay on living, and then suddenly after a month they're gone. It's a very strange coral. This is Mary Hagedorn from the Smithsonian Institute, and she was really helpful. With the second Sea-Core workshop, she asked for a fund, and she was very important to get Sea-Core going. And she works on cryopreservations of coral sperm and eggs. She works in Hawaii. This is very interested to work on the elkhorn coral, and she's actually the leading scientist for the fund that we asked for NOAA to start up this project in Puerto Rico.
3 minutes.
The midterm goals, thank you, Heather. To expand the network, new field locations and more species. And as you could see and hear, Dominique and Max, everybody is already busy with this. I would hope we can get on with that. And restoration pilot studies of elkhorn corals. This was a dream last year at the International Aquarium Congress. And I could tell you that during the FATEC that is really going to happen in Curaçao already this year. So it's going fast. I'd like to acknowledge all the people who helped us, especially Mary Hagedorn, as I told you. Iljana Baums, a very good scientist, very important because she knows the genetic diversity of the elkhorn corals in the Caribbean, and all Sea-Core members, and also of course our sponsors. I thank you very much for your attention.
Thank you for keeping perfect time and a very interesting presentation. Are there any questions?
Please don't tell Dirk that I throw this away. Any questions?
Okay, I just have one. What do you think is the main reason why this coral is shown such rapid decline compared to other species?
I really would not know. It's maybe somebody else, maybe Dirk has an idea about this, but it's the Caribbean. In the Caribbean, the only thing is that the Caribbean corals went to a bottleneck during the ice ages. So there are only 40 species left in the Caribbean, and I think they came from a very small base. And you can see that all the Caribbean corals are very hard to keep. It's a totally different story than in the Pacific corals. I know somebody always say, I grow them like chicken. Well, you cannot do that for Caribbean or in the Pacific corals, but Caribbean corals is I don't know how it happened, but it's another story. They're very sensitive and hard to keep.
Okay, thank you.
It's one question there, Dennis. Or are we on?
Yeah,
Can you just say who you are?
Dennis Thorny,
Yeah, thanks.
Vancouver Aquarium. The white band disease came through the Caribbean and wiped out most of the elkhorn corals before the big bleaching event, which occurred a few years ago. So at that time, we've already had lost a huge number of the elkhorns, and also affected cervicornis, also white band did, but it didn't affect a lot of the other species. But that's the reason why they kind of disappeared and why you have these dead areas of elkhorns everywhere.
Thank you.
Okay, thank you.